Hello and welcome to Naming Hydrocarbons. I'm going to move quickly since there's a lot of material in this particular video, so you may want to pause as you go along to make sure you can keep up with writing things down. I apologize for the rapid speed. We're going to start with some types of formulas. We're going to draw a lot of what we call complete structural formulas. Complete structural formulas are very useful because they show us everything that is in the compound, where it is, types of bonds, different what we call functional groups. So these are the most informative types of structures that we're going to draw. And I'm using an example of pentane. Pent means 5 and ane means single bonds. And I'll show you where you can find that in just a minute. A complete structural formula for pentane involves 5 carbons in a row. And then each of these carbons gets the rest of their bonding spots filled up with hydrogens. So a complete structural formula for pentane looks like this. There's also a shorthand way to draw this. I'm going to pause the video for a minute so you can take a look at this. So an acceptable shorthand for this molecule is just to use dashes, little stems for the H's instead of actually writing all of those H's, which will save you a lot of time. You do have to be very cautious with this though. Make sure that you do a nice job making very visible stems and remembering that they do all count as a bonding spot. So you have to be very cautious when you use that. A condensed structural formula looks at what's happening on each of these C's. So my first C right there is a C with 3 H's on it. My second C is a C with 2 H's on it. And then my third and fourth C's also have 2 H's on them. And then finally my end carbon over here is another CH3. This does allow me to see where I have things like double bonds, so there's a little bit more information here than a completely condensed formula, but a condensed structural formula is a little quicker and a little bit easier usually to fit in a given amount of space. My molecular formula is just telling people, hey, I got 5 carbons, I got 12 hydrogens. I'm not giving you any details about where anything is. This is helpful for doing things like GFM, comparing some compounds that we're going to talk about called isomers. But if there's a double bond here, we don't know about it. So we're going to use something called IUPAC naming, and we've used IUPAC naming before. This is just the organic chemistry rules for IUPAC naming. I've given you this first example, the structural formula and the condensed formula, so that you can start to get a look at what those look like. So the first thing we do is we identify our longest carbon chain, which is this right here. And I'm going to get you in the habit of numbering these carbon chains. We'll talk a little bit more with some more complicated examples of why this is important. So I've got 1, 2, 3, 4, 5, 6 carbons in a row here. Sometimes it's helpful to number these in another direction. As I mentioned, with more complicated examples, we'll talk about why you need to do that. We have 6 carbons in a row in this molecule. So we are going to go to reference table P, which is our prefix table. And reference table P says when we have 6 carbons in a row, our prefix is hex. So our prefix for this molecule is hex. Then we have to check out what ending we're going to have, and this is based on the bonds in the molecule. This molecule has all single bonds, so we're going to go to table Q. And when we have a molecule with single bonds, like this sample right here, those are the alkanes, and the endings have ane. So our suffix for this molecule is going to be ane. Next thing we need to do is see if we have any what we call substituents. And these are groups that branch off the main chain, carbon groups or other elements. Hydrogen does not count as a substituent. So in this molecule we have no branching groups, so we can cross that right out. So now we're going to make sure that we're actually going to be able to put the whole name together. We might have to sometimes tell people where there are things like double bonds. This particular molecule doesn't have any double bonds, no substituent groups, anything like that, so we're actually done. So now all we have to do is say, hey, my prefix is hex, my suffix is ane. This molecule is called hexane. Next molecule up here is a little bit more involved, so you're going to be able to notice here that we have this long chain right here, and then we have this branching group right here, which is called a substituent. And if we condense that branching group down, that is a CH3 group. It's condensed right here, so you can see it there as well. We're going to go ahead and we're going to number this in both directions. We'll be able to see why that's important in this example. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. We have 7 carbons in a row. Our prefix is hept. Our suffix is still based on bond type. We have all single bonds, so that's going to be ane. And now we have to look if we have any substituents. And you will not be given this table on the reference table, but you can see that it is based on the prefixes. 1 carbon's methyl, 2 carbons is ethyl, and 3 carbons is propyl. So you do need to be familiar with those. We do have what we call a methyl group. So we have this one methyl group right here. And we need to tell people where that is. So we're going to assign a number to tell. Sometimes we use it for multiple bonds. I'm going to add or substituents here because we're going to add a number to tell people where that methyl group is. Now the rule for numbering is any substituents need to be, their location needs to be indicated with the lowest possible number. This molecule has the ability to move in space. So we always have to make sure that we number in a way where we're using the lowest possible number to indicate position. So this carbon branch is attached to this carbon right here. If you numbered in this direction, that would be carbon 3. If you numbered in this direction, that would be carbon 5. The number 3 is lower than the number 5. So we're going to call this 3-methyl. Now we got to put the whole thing together. So we tell people my methyl is on carbon 3, and hept for my 7 carbons in a row, and ane for those single bonds. Now, it can be a little bit tricky when we start getting multiple substituents, and the best way to get used to this is doing a lot of practice. So we go ahead, we identify our longest carbon chain. We're going to number 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. We're going to look at our number of carbons in a row. When we go to table P, our prefix is hex. All single bonds tells me my suffix is ane. I have 2 methyl groups here. So what I'm going to tell people instead of just methyl is I'm going to tell them we have dimethyl, or 2 CH3 groups. Now I have to tell people where those are. If I were to number this way, those are attached to carbon 2. If I number this way, they're attached to carbon 5. Once you commit to numbering in one direction, you have to stay with it. Meaning you can't say, oh, those are on carbon 2 and carbon 5. That just becomes carbon 2. So anything that we've had in this molecule, we would number in this direction. And that can be a little bit confusing with more complicated examples. So we have to tell people that those substituents are on carbon 2. Because there are 2 of them, you have to say where both of them are. Just because we have 2 methyl groups doesn't mean they're both on carbon 2. So we're going to put this molecule together. This is 2,2-dimethyl. And remember, we have 6 carbons in a row, so that's hex in all single bonds. Gives us an ane ending. 2,2-dimethyl hexane. So this molecule right here, we're going to do our longest chain in a row. We go ahead and we number 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So we're able to say, okay, we're going to have oct. We have all single bonds, which is ane. Now, we're going to look at our 2 substituent groups. This substituent group has 2 carbons in it, so it's what we call an ethyl group. And this is still one of our regular old methyl groups. So if we number in this direction, we end up with our groups attached to 2 and 4. If we number in the other direction, we would be saying 5 and 7. 5 and 7 are higher than 2 and 4. We have to go all in one direction, so we're going to take 2 and 4 for our numbers. So we have a methyl group, and we have an ethyl group. Now our methyl group is on carbon 2. Our ethyl group is on carbon 4. They do have to have the appropriate numbers with them, and you'll see why when you start drawing these. So I already took care of my numbers up there. Now I'm going to put this together. Now, what do I put first, methyl or ethyl? Great question. You actually go in alphabetical order. If you were to flip-flop these, as long as your numbers are with the correct substituents, it's okay. So I will show you both ways, but the preferred way to do this is by putting them in alphabetical order. So this molecule is 5-ethyl, 2-methyl, and then again we add octane for my ending. So if you did this instead, 2-methyl, 4-ethyl, octane, that's totally acceptable at this point. What is important is that the 2 goes with methyl, the 4 goes with ethyl. If you said 4-methyl 2-ethyl, that would not be correct. That is different. So our next example has a double bond in it. So we're going to look and see our nice carbons in a row. We're going to go ahead 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we got 5 carbons in a row, which is going to be pent. Then we go to table Q. We no longer have all single bonds. So when you're looking at table Q, oh, double bond, my ending is -ine. So you're going to go ahead and make your suffix this time different. Your suffix will be -ine. Now, we do have to use numbering, same type of numbering, to tell people where our double bond is. Now, if we numbered in this direction, our double bond would be starting on carbon 3. Okay, so it's showing where the double bond, where we first see that double bond. If we number in this direction, our double bond starts on carbon 2. 2 is lower than 3, so we're going to go, we don't have any substituents here, but when we assign our number, we're going to use the number 2. So this is going to be 2-pentene. Now, the reason I want you to see the condensed formula here is you're going to notice that this carbon right here, usually the carbons have 2 H's. This one only has 1, and this one only has 1. That helps indicate that that double bond is there. So that takes a little bit of practice seeing that, but you should begin to recognize it more quickly. This is one that I gave you a condensed formula so you can take a look at it. So if we drew this out, we see CH3, CH2, CC, CH2, CH2, CH3. What is happening here, these 2 carbons are not filled up. So we're going to fill them up by, we can't add hydrogens, so we're going to add some bonds. So I can say, okay, this carbon right here has 1, 2, 3, 4 now. And then that fixes this guy too, 1, 2, 3, 4. So this tells us that we have a triple bond in this molecule. So if I number 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, I know I'm going to call this hept. My triple bond gives me an ending of -ine. I don't have any substituents here. Now I'm going to go ahead and assign a number. So if I were to go in this direction, my triple bond starts at 3. If I go in this direction, it starts at 4. So my triple bond is going to be at position number 3. So this molecule is going to be called 3-heptine. We will do these in class, so you can skip them for right now. We'll do them as practice together. Now we're going to look at drawing a structure from a name. So first thing we do is we make this thing called the carbon backbone. Pent tells me that I have 5 carbons in a row. 1, 2, 3, 4, 5. Ane tells me I have all single bonds. So don't do anything else there. And the last thing I do is I make sure that every single carbon has 4 bonds. This carbon on the end has 1 bond right now, 2, 3, 4. And I'm filling those in with hydrogens. And again, you can use just the stems. That's what I'll be doing in the future, but I just wanted you to see this right now. This guy right here, 1, 2, 3, 4. Oops. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And once your carbons are all filled up, you're done. Ooh, this one's trickier. 2-methylheptane. Hept means 7. 1, 2, 3, 4, 5, 6, 7. Ane means we leave those as all single bonds. We have to put a methyl, which is a CH3 group, on carbon number 2. So if I count from the left to the right, it doesn't matter. You could do this in either direction. I tend to go this way. This is carbon 1. This is carbon 2. And remember, once you've picked a numbering direction, you do have to stick with it if you have multiple things to put on there. So the methyl group, that CH3, you can draw it out like that, okay? The way to condense this, which you are always allowed to condense these even in structural formulas because you start running out of room, is to write it like that. And then I'm just going through here, and what I want to do is make sure that every carbon has 1, 2, 3, 4 bonds on it. So always double check that, and you'll notice when I started to make this one over here, I didn't really make it big enough at first. You need to make those nice and visible. Missing 1 hydrogen can cost you a full point on the Regents. 3-ethyl-2,4-dimethyl octane. So oct is 8. 1, 2, 3, 4, 5, 6, 7, 8. Ane, all single bonds. Then I'm going to go ahead and number 1, 2, 3, 4, 5, 6, 7, 8. On carbon 2, I need a methyl group. On carbon 4, I need a methyl group. So I'm going to make that guy go up. You can choose up or down. It's totally up to you, but you have to think about how things are going to fit. On carbon 3, I need to put that ethyl group. When you go then to fill in each of these carbons, what is very important is that you make sure, you already have 1 bond here, so 1, 2, 3, only 1 more H there. On this one right here, when you have that bond coming down, make sure it does not attach there. You don't want that to happen. That's a problem. And you just continue to fill in the rest of your H's. When we have a multiple bond, like in 1-pentyne, we're going to start by doing the same thing. 1, 2, 3, 4, 5. The 1 tells me my triple bond starts at carbon 1, which is going to be this carbon for me. So I'm going to put a triple bond right there. When I go to fill in my H's, this carbon on the end already has 1, 2, 3 bonds, so he only gets 1 more H. This next carbon already has 1, 2, 3, 4 bonds. He's full. 2 H's here, 2 H's here, 3 H's here. So be very cautious with these when you're counting them to make sure that everyone has 4. And if they have a triple bond or a double bond, take that into consideration. So 4-octene. Oct is 8. 1, 2, 3, 4, 5, 6, 7, 8. And I'm starting my double bond on carbon 4. 1, 2, 3, 4. And then I'm going ahead. And remember with this double bond, 1, 2, 3, 4, 1, 2, 3, 4. And you're going ahead and filling in the rest of those H's. The examples that follow we will work on in class tomorrow. We are all done. So these notes are also going to be saved so that you can copy them down separately from the video if you like.